Thank you so much, Graham, and it is my absolute delight to be kicking off Terrapin's Submarine Conference. We are living in a time of absolutely massive technological change that is going to have a major impact on communications networks, whether they're mobile networks, terrestrial fixed networks, submarine networks, and it's going to be an amazing ride over the next couple of years, starting right now. So what I'd like to do today is take you on a little bit of a whirlwind of some of the technologies that are going to impact all of your networks, and also present some new opportunities for you that are just on the near-term horizon, and talk about some new technologies in robotics that could help with submarine cables too. So here we go. First is augmented reality. Just out of curiosity, how many of you have tried on augmented reality glasses? Anybody? Raise your hand, a few of you. Many of you might have tried it with your phone, right? Right now, augmented reality is still in its infancy, but it's a technology that is set to really explode in the very near-term future as headsets become cheaper and as the definition gets higher and higher and higher. And it has a lot of uses. It has uses in business to consumer, making ads on a magazine or a brochure that you're looking at pop off the page and let you play with them with gestures. It has uses in the home where you might have floating television sets or a hologram chef helping you cook in your kitchen. But most importantly, it also has a lot of business applications, and that's why this industry is really going to start taking off over the next couple of years. It's been forecast that between augmented and virtual reality, we're going to have an industry that's worth about $120 billion per year by about 2020. That's huge money, and the bandwidth is going to get even higher and higher. So this isn't something that is just on the drawing boards. There are already companies around the world that are using augmented reality and virtual reality, oops, can we fix that? To help in real industrial situations. An example of this comes from Spain. Acciona Agua is a company that has a water sewage treatment, and they're using both AR and VR. With virtual reality, what they're doing is they're allowing people to train on all of these water treatment plants in a virtual reality simulation so that they can make mistakes without having any impact on real-world, mission-critical infrastructure. In operations, what they're doing is they're outfitting their maintenance staff with augmented reality glasses that allow them to not only have an audio-visual feed with people back in the control office, but also literally have real-time SCADA feeds carried around with them, and in their field of vision, they're able to look at a pipe and see exactly what's in that pipe, to see the water pressure, to see the temperature, to see something like a valve that will be able to tell them which way to turn things. It's going to have a tremendous impact on so many different industries, but it's also going to have a massive impact on bandwidth. And there are a lot of different things that are going to impact bandwidth going over networks over the next 3, 5, 10 years and beyond. And coming from the telco industry, one of the things that I wanted to know is, what does this mean with bandwidth? Today, it's very common to be filming in HD. So with HD, if you have uncompressed bandwidth, you're looking at 3 gigabits per second, but you can compress it down, and depending on what codec you use, you can get it down fairly good. In my examples that I put together here, I used a frame rate of 60 frames per second and a color saturation of 8 bits. When it comes to calculating bandwidth, it's really fiddly. And that's why I decided to create this chart, which I invite you to take pictures of, and I'm going to send to the organizers afterwards so that you have a copy. There's a really good website that I found that has a calculator that lets you play around with different things, because frankly, I could not find a good source. So right now, HD is the norm, but 4K is actually the norm for displays. My computer has a 4K display. My big monitor goes even higher. And we're going to start to see this become even more common. 8K is already on the horizon right now. There are companies who do projectors for theaters and places like this that are starting to release 8K projectors this year. And at the end of this year, NHK in Japan is actually planning to release an 8K video channel to be able to stream a live sporting event. And it goes beyond that too. It's going to go to 16K and eventually to 32K. So what happens is that every time we move from one to another, what we're doing is we're doubling the pixels in terms of the width and also doubling them in terms of the height. So basically 4 times the number of pixels. Uncompressed bandwidth is going to go from about 3 gigabits per second for today's HD all the way up to about 794 by the time we get to 32K. And with 32K, you're going to have what is in effect lifelike 3D holograms that do not require anybody to wear any glasses. It's not going to be like the Star Wars Fritzy hologram that you've seen of Princess Leia fritzing in and out. It's going to look like somebody real is standing next to you, and you're not going to be able to tell the difference. There are a lot of scientific applications, especially with augmented and virtual reality, that will make use of this ultra-high definition bandwidth. Scientific visualizations, for example, architectural drawings where you want to be able to get into all the individual details. We'll also see super high bandwidth both in video for television, we'll see it for gaming, and we'll also especially see it in augmented and virtual reality. How many of you have heard of the Netflix effect and how it impacted telco networks? Most of you, I expect. Well, that is nothing compared to what's going to happen over the next few years. Another thing that is really going to impact networks is this whole move to smart cities and putting sensors and controllers everywhere, doing lots of different things, giving real-time bandwidth or real-time information to all kinds of applications. In Italy, Trenitalia is already using sensors on their trains to change how they do maintenance. So like many train operators, they used to do maintenance on a schedule just because it was time to do something. Now, using AI and advanced analytics and the sensor data, they're only doing maintenance when something is actually going wrong. They've got a budget of 1.3 billion euros per year, and they're reducing their cost by 8 to 10% per annum by using the Internet of Things and smart cities. It's big money, but it needs to be real time because people's lives could be at stake. There's another really cool project happening in Chicago that I saw a few months ago when I was out there. It's called the Array of Things. And what they're doing is mounting on street poles what looks like little beehives, but in them are sensors that measure all kinds of things. Temperature, all kinds of pollutants, pedestrian traffic, vehicular traffic, ambient noise, vehicle noise, you name it, it's being measured. And they're looking to deploy 500 of these throughout the city and open source this data. They want to use it for city planning, but they also want people to be able to be creative with this massive data set that these sensors are going to create. One of the applications that someone has come up with as an idea is, let's put something together where if someone has asthma and they're walking to and from work, let's design an app that will in real time navigate them around a path where there are no pollutants that will kick off the asthma, and also have other pedestrians nearby so that it's actually a safe walking place. The sky is the limit once you start to get all of this real-time data and open source it and make it into massive data sets. And this is where technologies like 5G come into play, and edge computing, really low latency, and in some cases high bandwidth too. we're going to see things like this picture here of self-repairing cities. There's a project in Leeds in the UK that's being run out of the University of Leeds in conjunction with the council and national government support and a whole range of industry collaborators, where they are looking to design fleets of tiny little robots that will sense defects in a city before they become major problems. They want to have the world's first self-repairing city by 2050, where literally these fleets of robots will act like the white blood cells in the human blood system and detect a problem before it happens. So one of the modalities that they're thinking of are drones that have manipulator arms that are able to perch on buildings or light posts and be able to fix things, and maybe someday even electrical wires. Another mode that they're thinking of is forget about potholes. Let's make that a thing of ancient history and detect potholes before they become big problems. When I first started to talk to the lead scientist about this project in 2015, I said to him, well, what are you going to do? Design, fleets of robots that fly around the streets and detect potholes? And he said, no, actually, what we'd like to do is partner with industry, especially the driverless car industry, because the driverless cars are going to be packed with sensors. They're going to have high-definition cameras. Let's get feeds from them and use that as the trigger. But in the meantime, because it's a research project, they've gone back to what I thought was my original idea. They've designed 3 sets of drones, one that flies across the streets and finds a pothole in the making, another drone that actually goes off and does the prep work. It does a little bit of digging, and then a third one that actually goes out and has an onboard 3D printer that prints asphalt or tarmac and fixes things in real time. They have an even more ambitious project where they want to launch robots into boreholes deep underneath the city and be able to communicate back what's happening underneath the city. Of course, communication is going to be a big issue on that one. And this big picture here is a bridge bot that they've designed. It's actually able to go upside down, and it's already doing inspections of bridges in Leeds. Now, you might think, all right, that's science fiction-y. Well, let me tell you about a project in my hometown of Sydney. In Sydney, there's been a collaboration between the New South Wales Roads and Maritime Department and University of Technology, Sydney, to help out with keeping the Sydney Harbour Bridge safe. The bridge is a massive steel structure, and it requires regular maintenance for safety. And grit blasting is something that's very hard and very dangerous for humans. And about 9 years ago, they started this collaboration about how can we design autonomous robots to help us out with this problem. And they used the inchworm as the basis for designing this robot called Croc. So it moves along like a worm. It's able to navigate an unstructured environment completely on its own, and then it feeds very high definition images into the GIS system, and then the robots can then do grit blasting if the bridge engineers determine that that is something that needs to happen. Today, there are 2 robots on the Sydney Harbour Bridge, Sydney and Rosie, and they are working autonomous robots. Speaking of autonomous, we're going to see lots and lots of driverless cars. And frankly, every single auto manufacturer is going to have a vehicle that operates in autonomous or semi-autonomous mode by car year 2020 or 2021. The auto industry is making massive investments in this, and massive investments in artificial intelligence, a lot of investments in sensors. And by the way, most of these are going to be electric or hybrid electric. But that's also going to be just the tip of the iceberg, because what we're going to see are vehicle-to-vehicle networks. So not only will the vehicles have sensors that correspond geospatially with GPS signals, they're going to be communicating to this brand new network in the cloud that will be allowing cars to communicate to each other. So let's say one of these cars hits a pothole, it'll transmit to the cloud pothole at a precise coordinate, and the next car will be able to avoid it, and so on down the line. And then, not only that, but infrastructure is going to be retrofitted with sensors. So traffic lights will be broadcasting, I'm green, and I'll be green for another 30 seconds. Stop signs will be transmitting their precise location. Speed limit signs will be transmitting the speed limit in every given space. Say goodbye to traffic infringement revenue, state and local and federal governments. It's going to go away, but this is a massive new opportunity for telco operators. It's not clear yet exactly what technology might be used. It might be 5G, it might be something else, but there's going to have to be communications, and the question is, whose network is it going to be? And many of you are telco operators, so why not your network? We're also seeing a drone revolution. How many of you, by the way, own a drone? Anybody? Oh, a couple. And they're probably manually controlled, right? Well, right now, that's the norm, but where they're going is completely autonomous drones, just like we have completely autonomous driverless cars. Drones are already being used in the telco industry for asset inspection of cell towers. They're being used in the electricity industry. They're being used for real estate and videography. They're being used to go into disaster sites for search and rescue missions. But perhaps one of the most exciting things is flying taxis. And this bottom picture is me with the world's first flying taxi, the EHang 184 out of China. I saw it last year at CES. And got to have a picture of me with it. It's a working prototype, goes 100 kilometers an hour, can carry one person for about 20 minutes. Lots of companies are getting into this whole world of flying robots. This is a picture from New Zealand. It's from a company called Kitty Hawk, and it's called the Quora. And this is a really interesting project because it's been happening in stealth mode between Kitty Hawk and the New Zealand government for the last 18 months in stealth mode. So this is the important bit, is that it's been tested in combination with the regulator. So Quora takes off, vertical takeoff and landing like a helicopter, then flies horizontally and then lands like a helicopter. It's electric. It's 100% autonomous. It can carry 2 people. You get from place to place using a mobile app and telling it where you want to go. And guess what? It can go at up to about 100 miles per hour, 200 kilometers per hour, and it has a pretty good radius too. And they're looking to launch this by about 2021 as a commercial service. They're not the only company. Uber Elevate is looking at this as well. They're looking to leverage their platform for for cars, and later driverless cars, and for food delivery, and for package delivery, and now they want to do flying taxis, and they already are working with NASA in the United States at looking at prototypes in Dallas, Fort Worth, and Los Angeles, and they're looking to expand into other countries as well. This is going to happen in about the 2021 time period, where we're going to see these be part of our environment. And guess what? That presents massive opportunities for telco operators, because once again, we're going to end up with in effect, a vehicle-to-vehicle network that is a 3-dimensional representation of drone traffic. It's estimated that in any given large-sized city, there might be 10,000 autonomous drones per day that are traversing a city. So in the US, NASA is taking the lead, along with Amazon, who first proposed this, of designing segmented airspace where drones that are completely autonomous fly at higher levels, and they've got lots of sensors, and manually controlled drones fly at lower levels, like for hobbyists or line of sight, and there'll be no-fly zones and so on. Once again, communications networks are going to be needed, and there's a massive opportunity here. Artificial intelligence, if I had to say one technology that is going to impact the world more than anything else, it would be AI. And here I'm talking about machine learning and deep learning and natural language recognition and image recognition and facial recognition and emotion detection, driverless cars and smart robots. Well, let me talk about robots for a moment in the submarine industry. Some of you may be familiar with this picture. It's paired de Fermat. It's a cable laying and repair ship, and it has this robot, Hector 7. It's actually a remote operated vehicle. So it's a robot, but a human is actually controlling it. And as you would know, submarine brakes are really a big issue. And what happens typically is that if there's a break, you get an alarm in your network control, and then within a few hours, you figure out where there is the problem by sending laser pulses down the cable. And then you have to find a repair ship, and hopefully it's one like this that has a robot that is also able to help. But it's a very manually intensive process, and it takes a lot of time, especially if the ship is deployed doing other things. So once this ship gets to the place where there's a broken cable, the cable may not be in its original position. It may have been dragged along by, let's say, a fishing trawler or an anchor or an earthquake or some other seismic event. So one of the things that has to happen is divers go down and they identify where the cable is, and then once that happens, a human controlling Hector brings the cable up, and then you can patch it, add new cable to it, put it together, and then bury it again. But you know what? There's a lot of room for additional automation with robotics in the submarine cable space. I love talking to roboticists, and one of the nearby universities is the University of Sydney that has the Australian Centre for Field Robotics. Let me show you what they're doing with some underwater underwater robots right now. And there's 4 of them that I'm showing you here. They are all completely autonomous. And they're able to basically do sensing of the environment without a human controlling it. And they have diver rigs as well. And then in this last picture, they actually have a deep water stereo system that is able to record, including the geoposition, exactly where things are. And when I was talking to the roboticist, one of the things I asked them is, are you actually partnering with anybody in the submarine cable industry? Because these kinds of robots would make a whole lot of sense. And the answer was no, that the telco industry really hasn't expressed much interest to us. And I was really perplexed. I thought, wow, this is an opportunity waiting to happen. We've got robots that can autonomously go underseas. They can help out with marine surveys. They can help figure out where cables are if something breaks. And they can help fix things too if you put on the right manipulator arms. Why not use technologies like this to help you in the submarine cable industry? And someday, we will have cities in outer space, and you might think, Shara, why are you talking about outer space? We're not going to be laying submarine cables to another planet, for heaven's sakes. No, we're not, but we will be communicating with other planets. The reason for showing you this is that I was recently watching a documentary that was done by NASA and National Geographic, and it took place back and forth between 2016 and the year 2037, and it was about a colony on Mars that suffered a major disaster. Their nuclear plant had an accident. They were relying on solar power, and there was a major dust storm, so there was no solar power. And that's actually just recently happened on Mars, so it's very realistic. But what had happened is that they had no power for the colony, and they needed to go out and find out where the cable was so that they could fix it and repair it. And it was incredibly sort of obtuse how they designed this, in that the cable didn't have any sensors on it. They had what was a rover of 2037 that was mostly autonomous, but it only had a certain amount of range and couldn't go all the way. So an astronaut got out of this rover and went to the very end of his tether and still couldn't find the cable, once again, because there was nothing coming from the cable telling him where it was. And then he untethered himself, took his life in his hands, and magically found the cable and got everything repaired. The moral of the story is, as you're laying submarine cables, I think it actually makes sense to put in very long-powered, low-usage sensors that will help you to know exactly where a cable is, every single portion of the cable, real time rather than relying on sending laser pulses down the cable when something breaks. So I hope I've given you some ideas. There are a lot of opportunities in the telecommunications industry to use new technologies to develop new networks for the technologies like driverless cars and drones, but it's also going to require a massive investment, and we're also facing a massive bandwidth tsunami with higher definition TV and video and augmented and virtual reality. Thank you so much for your time this morning.
Thank you very much, Shara. I've been told by my bosses that we have time for 1 or 2 questions. Do we have any questions?
If not, I'll be hanging out for a little while.
They will be.
I will be, yeah.
Absolutely. Okay, Shara, well, thank you so much for that insightful presentation. So now I would like to introduce Elaine, who's going to come to the platform to introduce her panel. Before I do that,